All right, what's up, Algebros? Mr. Yates here. This is the continuation of what we did on the block day after we did the test. Okay, so we're going to continue talking about correlation. So, relationship between two sets of data. Okay, we're going to add in also what's called the line of best fit today. So, I'm going to start with out of the three vocabulary words there at the top of your page. I'm going to start with the third one actually, because that's one we already talked about. Okay, and it's that word correlation. Okay, so that's a measure of relationship between two variables, right? So we got our x and we got our y. So it's two different sets of data, whatever it is. Okay, we're going to figure out about their relationship, and then remember how we talked about after the test the other day, okay, or yesterday. Um, it could be a positive correlation, it could be a negative correlation, or it could have no correlation at all. All right, so two things we're going to add in today. Okay, first one, it's called a trend line. You maybe heard me say things about trends the other day. Okay, so a trend line is a line on a scatter plot drawn near points, and it just shows a correlation. Okay, so I was kind of doing it with one of my tools, okay, here on the iPad the other day, and it was just kind of where I showed you, okay, going from left to right, if it's going up, it's positive, or it's going from left to right, it's going down, it's negative. Okay, a trend line is just something that you draw. All right. The other thing that we're going to talk about, it's actually an equation, and what that equation forms is called the line of best fit. Okay, because here's what I want you to think about. If I draw a line, in the middle of a whole bunch of points, I can be somewhat accurate with it, but I'm drawing it, right? So I'm not going to be as accurate as possible, most likely. Okay, I suppose the chances there, I suppose, as low as it may be, that I may draw the perfect line, but it's probably not going to happen. Okay, so then what we can do is we can take calculations to come up with, as it says here, the most accurate trend line. Okay, which is from an equation. All right, so it's the most accurate trend line on a scatter plot showing the relationship between two sets of data. All right, so first thing we're going to work on is, graphing some data, looking at it, okay, drawing a trend line. Forgive the barking dog in the background or family doing family stuff, but yeah, I'm making this at home, so that's what you get. Sorry. Anyway, all right, so we've got a table that shows altitude of an airplane and the temperature outside of the plane. Okay, so we got plane altitude and outside temperature. So first thing we need to do is look at it and decide, okay, what's what? Well, our altitude is going to be our x values. Okay, our temperature is going to be our y values. All right. So if you look at this graph and the table, well, the table for altitude goes from 0 up to 5,000. Okay, and then the temperature for the graph, if you look at it, it really, if I look through there, this one right here, this 61.3, that's really the highest value. And then my lowest value, if I look all the way down here, looks to be 0.6. Okay, so it looks like my temperature's got to go somewhere between 0 and, about 60, 65, somewhere in there. And then obviously my altitude's got to go from 0 to 5,000. Well, obviously I can't do that, those by ones. So what I'm going to do, I'm going to label it first and say, okay, my y values are my temperature. Okay, that means that my x values are my altitude. All right, so I'm going to have to decide on a scale that would sort of make sense. So I'm going to do my y values first. Okay, so it looks like I have 1, 2, 3, 4, 5, 6, 7 lines to deal with. And a second ago I said, well, it's probably between 60 and 65 is kind of where I need to go. So I think I'm going to do this by tens. All right, so let's label those lines. So label yours, 10, 20, 30, 4, whoop, not 45. Getting a little ahead of myself. 40, 50, 60. I have to take my label and move it a little bit here. Hold on a second. Okay, let me get that out of the way. There we go. Okay, and I'll make that 70. Okay. So then if I need to go to 5,000 on the x's, let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines. Okay, well, let's see, what if I go by 500s? If I need to get to 5,000, because that would mean I need 10 of them, so I think that should work. All right, so let's do 500 and 1,000, 1,500. Hopefully you can sort of see that. 2,000, You might have a better way to do this than I'm doing it. It's kind of hard to read there, isn't it? But that's 2,500. There's 3,000, 3,500, 4,000, 4,500, and there's 5,000, and that's as far as I needed to go. So I can add the 5,500 there at the end if I want to. All right, I'll add it in there. Okay, so let's plot the points. Well, if I look at the temperature, right, and I look at all these, well, they're decimals, so I'm going to have to estimate a little bit, okay? Which, remember, we talked about one of the big goals for this unit was to make predictions. So it's not always going to be perfect, okay? So that's okay. All right, so let's see. First one is 0.59, so that's going to have to be, oh, no, I don't want my blue one, I want my red one. There we go. Somewhere right in there. Okay, then I need 559.2, so that's about 60, right? So somewhere right in there also. And then I need 1,061.3, so I'm going to go a little bit over it. 1,555.5, so just about in the middle between 55 and 60, or between 50 and 60. 2,000 is 41, so there's 40. I'll go a little bit above it, up here maybe to close to 42. Okay, excuse me, 2,500 is right about 30, 29.8. Pretty much right in there at 30. Okay, let's see, 3,000. All right, that's what we're on. Yeah, 3,000 is, again, right about there at 30. Tad higher. 3,500 is down to 18.1, so now I got to drop all the way below 20. Go somewhere in there, maybe. Okay. And then 4,000, back up to 26.2. So we'll go somewhere in there. 4,500 down to 12.4, so somewhere right in there. And 5,000, we need to be all the way down at 0.6. So we've dropped almost all the way down to 0. Oh, that reminds me, I didn't put a 0. Let's put a 0 on that graph. There we go. Okay. So we want to complete the statement below using the words increases or decreases. So as the altitude of the plane blank, the temperature outside the plane blank. Okay, well, altitude is all this down here. Okay, so to increase it would be going to the right. All right, so I'm pretty sure that's what we're going to have to put there. All right, as the altitude of the plane increases, because I don't want to work backwards on my graph. So as that increases, the temperature outside the plane, well, if you look at it, temperature started up here, it kind of went up a little bit, but for the most part, its trend is to decrease. Okay, so what type of correlation does that scatter plot show, right? This is what we talked about real briefly. Okay, on block day, it was that, yeah, that's kind of going down from left to right. So yeah, this is a negative correlation. As the independent variable, which is the altitude, increases, the dependent variable, which is the temperature, all right, decreases. Okay, so let's talk about, okay, well, how do I get from there to the equation of a trend line? So meaning we're getting to the line of the best fit. So an accurate trend line, okay, so that's what we're going to start with, is the drawn one. Okay, so an accurate trend line should fit the data closely. All right, there should be about the same number of points above the line as below it. Okay, because think about that. I want to try to get it right in the middle. So if I have the same number of points above my line that I've drawn as I do below, as long as it's an even number, I can do that. Okay, then my line's probably going to be pretty accurate. All right, if I kind of do, like I have my line goes where there's a whole bunch on one side and one on the other, well, then I've kind of skewed my data. And remember, this is about making predictions, so my predictions aren't going to be very good. All right, so now we're going to make a scatter plot of the data in the table. So this is about weight of a panda, right? As a panda grows, all right, if you've never seen any panda videos, look them up. They're a crazy creature. They fall. They do all kinds of weird stuff. So if you have like I don't know, probably TikTok, there's probably a bunch of them there, but Twitter accounts or whatever, look up some panda videos. They're pretty funny. But anyway, side note. Okay, so this graph looks like it is already labeled for us, so that's good. We don't have to worry about that. So now we just need to plot our points. Okay, so let's do that. So let's do age 1 month. So that'd be the first line right here. Okay, because here's our months here, here's our weight there. right? So 1 month about 2.5. Well, let's see. I got to look at my scale over here. Okay, if this is 12, I guess that means it's going by sixes. So that must be 6, 12, 18, and so forth. Okay, so then 2.5 is going to have to be less than that 6. So it's going to have to be down in here somewhere. Be pretty low on the graph. All right, over to 2 and up to 7.6. Well, we said each y line was 6, so we're going to go a little bit above 6. We'll say that's 7.6 in there somewhere. Over to 3 and up to 12.5, so really just barely above 12. Okay, since we're going up by 6 every line. Over to 4 and up to 17.1. Well, this line right here would be 18, right? So we've got to stay a little bit below it, so somewhere right in there. Okay, now over to 6, so we're going to skip 5, go up to 24.3. All right, well, there's a 24 right there, so we're probably pretty much right on that point. Okay, I try to go just a tiny bit above it. Over to 8 and up to 37.9. So let's see, there's 36. So we'll go up a little bit above 36 up into here. Over to 10 and up to 49.2. So if that's 48, we're going to go a little bit higher than 48. And over to 12 and up to 54.9. So let's see, if I'm adding 6 every time, that means this is 54 right there. So I'm going to go up just a bit above it. All right, on 12 there, let's see. So right in there. Okay, so we've made the scatter plot. Okay, so next thing it says to do is to draw a trend line. Okay, so you're freehanding this. You guys know I can cheat a little bit here on my iPad, but I'm going to count my points. All right, I've got 1, 2, 3, 4, 5, 6, 7, 8. So what I'm going to attempt to do when I draw this is to try to have 4 points on either side of the line, and these points are pretty close. So I think that's going to be relatively difficult on this. All right, but let's see if I can do it here. So again, I'm going to cheat a little bit with my tool that kind of straightens things out for me. So it looks like I've kind of got 4 that goes 3 there up at like 8, 10, and 12, and maybe the one down at 3. So then you kind of see that if I let go of it there. So I've got 1, 2, 3, and then kind of 4 on that side of the line, and 1, 2, 3, 4 pretty much on the other side. So I think I did pretty good there. Okay, but it's drawn, right? It's not going to be completely perfect. So what I'm going to do is just what it says. I'm going to choose 2 points that are on the trend line. Okay, so I think I'm going to say that my point right here at 4, okay, and I'm going to use that from the table. So I'm going to say the point 4 and 17.1 is on my line. Okay, it also sort of looks like, well, it's off a little bit, but I want to use it anyway. Okay, I'm just going to use that 6. I don't know why. My line is a little off that I maybe could have used the 2, but for today, just do this one with me. Use the 6. Okay, so that we're all consistent here. Okay, so what I've done so far is, I've drawn a trend line, so by myself. So I could use that to make predictions, but it's not going to be the best predictions. Okay, when this says right here, now write the equation of the trend line. Okay, we're talking about the line of best fit. So if you want to write that in, okay, is what that is. The line of best fit is what that is. Okay, I'm going to let that erase so that I have some room to work here. All right, because now I'm going to find the slope. Well, I've got 2 points, so I know if I have 2 points, I could just use slope formula. I could put it in my little t-chart if I want to, but I'm just going to use slope formula. So I'm going to take the 24.3, since that's the second y. I'm going to subtract the first y, which is 17.1. Okay, I don't want to put that over the second y, which is 6, minus the first y, or excuse me, the first x, which is 6, minus the first x, which is 4. So I'll just do that subtraction. That's 7.2 over 2. We can go ahead and finish that division. Okay, and there your slope is 3.6. Okay, so to find y-intercept, well, remember what you can do when you have the slope and you have points. You could use point slope if you want to. All right, so if you want to pick one of those 2 points and use point slope, I'm going to do something that we've learned, okay, that we don't do a whole lot, and we have done some of this. I'm just going to solve for b. So I'm going to use the first point, because remember, really what I have so far is this. All right, I don't know what b is. Okay, so that's my goal. So what I'm going to do is I'm going to use this first point, the 4 and the 17.1, right, and substitute for y and x, and then just solve it for b. So this is 3.6 times 4 plus b. All right, so let's see, 17.1, 3.6 times 4. Oh, let's see, what is that? We'll do it by hand. What do you say? So 3.6 times 4, 6 times 4 is 24, times 2, so 12 plus 2 is 14 to 1 decimal place. Right, will be 14.4. Hope I did that right. That'd be kind of embarrassing. All right, and then if I subtract the 14.4, okay, from both sides, then this will cancel out. So let's see, 17.1 minus 14.4, I believe that is 2.7. So there's your y-intercept. So now our next goal here was to write the equation in slope-intercept form. Oh, I need to write my y-intercept there on the line, don't I? Okay, so that's 2.7. All right, so there's your b. So then the equation for line of best fit is 3.6x plus 2.7. Okay, so now I can use that to make as accurate predictions as are basically possible on this. Okay, because I used data to create that equation as opposed to just my own line, just kind of drawing it. So then the next two things are to make some predictions. So what's the approximate weight of a 7-month-old panda? Well, months, okay, is your x values. So I'm going to take that 7 and I'm going to plug it in. All right, so let's go here. There we go. Okay, so kind of run out of space here. I'm going to do this down here on the right. So let's see, I'm going to take y equals 3.6, so I need to put in 7 for months, okay, plus 2.7. All right, well, if you calculate that, if you multiply 3.6 times 7 and add 2.7, okay, so if you want to do that in the calculator, right, you can just type this right here in the decimals. You don't need the y equals. Just type that in because there's no variable. It'll calculate it, and it should calculate out to 27.9. So a 7-month-old panda should weigh approximately, anyway, okay, 27.9 pounds. All right, well, what about a 15-month panda? Well, same idea, right? Except now I'm going to do 3.6 times 15 plus 2.7. Okay, and if you put that into Desmos, just like it looks, right? Just like that, then you should come out with 56.7. So that means it should weigh approximately 56.7 pounds. So think about those two answers, right? That's way more precise than it would have been from me just going up here and saying, I think it's like right there. Like, I don't even know what number that is. That's, somewhere between 18 and 24. Okay, so you see how much more precise the equation for the line of best fit can be. All right, now let's see if those even make sense. So 7 months would be right here. Okay, so if I follow my line up, right, somewhere right in there, we said it's going by 6, so somewhere right around 30. So yeah, a little bit less. Okay, so somewhere right in there, that makes sense. And then 15 months would be over here somewhere. Okay, so if I go up, is it going to be somewhere around 56.7? Yeah, probably so, because 54 was right here. So yeah, that my two answers make sense. Okay, so from scatter plots, right? Identify what type of correlation, so positive, negative, or none. Okay, know that a trend line is one you just draw, so you can make somewhat of an accurate prediction. All right, but then the line of best fit is an equation that creates a line that's way more accurate, okay, because it uses actual calculations from your data. All right, so hopefully all that sunk in. All right, you have some practice to do, and then I'll see you soon.